It's the Math 600A Unit 3 practice test. And we're winding our way down through the semester. And here we go. I think we have 20 questions today. And there's a little bit on the metric system. So that's where we're going to start. Question 1 has to deal with the metric system. First I need to get some pen color. And let's see, it's not giving me a lot of colors tonight. There we go. I'm going to go with green. Kind of in a green mood. Alright, the modern metric system, or International System. Units of units is abbreviated SU. System of units, no, it's the International System, it's IS. So that would be false. The International System of Units, it's called the IS. So the basic metric unit of length is a meter. That's right. A meter is about a yard. So that's true. And to divide a decimal by number by 100, move the decimal 2 places to the right. Well, let's say we have 100, and we divide it by 100. That would equal 1. 100 over 100 is 1. So if we were at 100, we would move the decimal 2 places to the right, and that would give us 1. Because there's our 100, moved it 2 places to the right. Move the decimal 2 places to the right. We did it. Alright, the first 3, that was easy. Let's keep it going here. How many centimeters are in a meter? Centa is like century. It means 100. Like a century is 100. A century run is usually 100 miles. So I'm going to say centa. Centa means 100. Okay, which digit is in the tenths place? So if you see the TH, it means it's to the right of the decimal, because this is the ones, the tens, hundreds. And then we don't have a ones place, but one, this 0.2, that's 2/10 of 1. So this is the tenths, hundredths, thousandths. Like a dime is a tenth of a dollar. So that's why a dime is 10 cents. A tenth, well, this is the tenth spot. So which digit is in the tenths place? The 2 is. So where is it? Down here. And we were already up to number 6. Let's see. Move it down. There it is. We have to use a decimal fraction. Okay, a decimal fraction. That's a weird term. So what we have here, that's a whole number, 9. So let's just put 9 out here. And then we have 0, 0, 3. And so we need a number with one more than that. So yeah, so 9 over 3 thousandths. Because the denominator has to have one more than the number of digits in the numerator, because it's less than 1. So the other way we could do it is tenths over 10, hundredths over 100, or thousandths. The 3 is in the thousandths place, and so we have to have it over 1,000. So that's the number I'm looking for, 9 and 3 1,000ths. There we go. And I'm asked to round to the nearest hundredths. So this is how I round. I put a line under the number that's where I want to round. There. And I knew when it drew a circle it was going to go away. There. Okay, so the 4 is the number where I'm supposed to round. Round to the nearest hundredths. You look to the number to the right. 5 or above, give it a shove. So 7's above 5. So I'm going to give this number 4 a shove. 5 or above, I give this a shove. And all that's saying is, that's a 5. all that's saying is 2.9471 is actually closer to 2.95 than it is to 2.94. It's closer to this number, so this is how we write it. Because this is only, if I added 29, I would be at 2.95. Otherwise, I would have to subtract 71 to get here. So this, where's my correct answer? Right there. So that's how you round. Underline the number you're dealing with, then look to the number to the right. 5 or above, give your number a shove. 4 or less, let it rest. Okay. Use front-end estimation to estimate the sum of these numbers. Okay. So I'm going to say this is about 89, and this is about 21. Or I could even go more and say this is about 90, and this is about 20. So I'm going to come up with about 70. About. Not exactly, but pretty close. The answer is going to be pretty close to 70. Not exact. Which of the following statements is true? 4.1 equals 4.1. My computer's just messing. It's just thinking right now. There, it's done. Okay. 4.1 equals 4.1. That's true. 9.01 is less than 9.02. No, $9.01 is less than $9.02. This says greater than. I think I said that wrong, but this says greater than. 9.01 is not greater than 9.02. 11.7, this is $11.70. This is $11.68. You could put a 0 on here. So that's not less than. That's not true. 9.5 is not equal to 9.05. This is a lot more. This is 9.50. That's $6.50, where this is the $6.05. So we know the first one was true. None of the others are true. We are on to number 10. And after that, we'll do number 11. Uh-oh, story problem. And it deals with time. Reagan, Susie, Molly, and Isabella ran a 800-meter relay at this track meet today. If their times were 29.5, 25.8, 26.14, and 25.71, what was their total time? Well, let's just add them up. 25.60. And remember, when we add decimal numbers, we line up the decimal. Not when we multiply, only when we add. And I just put a 0 on after the 6 as a spaceholder. So I like them all to have the exact number of significant digits here. 25.71. Okay, now it's time to add. 0, 8, and 4 is 12, and 1 is 13. Carry the 1. 1 and 6 is 7. 8. 8 and 7 is 15. 5. Bring my decimal straight down. I think I said 15. So there's 6 and 5 is 11. And 6. 11 and 6 is 17. And 5 is 22. There's my 2. Carry a 2. 2, 4, 6, 8, 10. So I have 102 minutes and 53 seconds. Oh, except for, you know what? I shouldn't have carried that 1. Yeah, I have to do this separate. You can't add time like that because this assumes there's 100 seconds in a minute, and there's not. Oh wait, 29. These are all in seconds, so I think I am all right. So 102.53 seconds. Yes. Scratch that. I was thinking something. I thought we were going seconds and minutes. Okay, Jackson bought 5 pounds of roast beef for $3.14 per pound. How much did he spend? Well, 1 pound cost him $3.14, but he bought 5. So we could add $3.14 5 times. That would give you the right answer. We just put a $3.14, $3.14, $3.14, $3.14, and add it up. Or we could just multiply by 5. And when you multiply, you do not need to line up the decimal. We just multiply, and then we count how many decimal spots we have. So let's just do it, and I'll show you how. So 5 times 4 is 20. 0, carry the 2. 5 times 1 is 5, plus 2 is 7. And there's the decimal. We don't bring it straight down. We're going to wait. 5 times 3 is 15. So there's my number, 3.14 times 5. 314 times 5 is 1,517, but we got 2 decimal spots. 1, 2. 2 decimal spots, so now I got to move it over 2 decimal spots. 1, 2. I'm going to put it in right there, so it's 15.7, and that makes sense. If 1 pound is 3, 5 pounds would be about $15. All right, now we got order of operations, right? You guys remember that? PEMDAS. PEMDAS. Parentheses, exponents, multiplication, division. We do those left to right. Don't forget that. Left to right. And then addition, subtraction. And we do those left to right. Okay. So first parentheses, there are none. Exponents or square roots, there are none. Multiplication, division, left to right. So we just got this. 2 times 3.4. 2 times 3.4 times 2. 8. 6. 1 decimal spot, so 6.8. So now I'm going to rewrite this. I have 10 minus 6.8. That's our 2 times 3, plus 6. And now we do addition, subtraction from left to right. So 10 minus 6.8, that's 3.2. You can trust me. 3.2 plus 6. So I get 9.2. Doom, first answer is the correct answer this time. And number 13, Jonathan. That's my name, except for it says John. I'm not Jonathan. But is cutting a 26-inch board into 2.75-inch sections. How many whole sections will he end up with? Well, that's this 2.75 going into 26. How many times can you get 2.75 and 26? And we haven't done much division with decimals, so let's do it. You can't have a decimal out here, so I got to move this 2 spots. So now I have 275. But if I move that 2 spots, I got to move this imaginary decimal here 2 spots. 1, 2, and then put it straight up here. So 275 does not go into 260. But it goes into 2,600. Let's try 9 times. This is where I wish I had a calculator. 9 times, I said. Every time you see that circle, it means it's going to disappear on me. 9 times. There, it stayed. Okay, 5 times 9 is 45. Carry a 4. 7 times 9 is 63, plus 4, 67. And 9 times 2 is 18, plus 6 is 24. And yeah, that works. So 2,475. And I gotta do subtraction. So borrow, make you a 5, make you a 10. Then borrow from you, make you a 9, and you a 10. And 5, 9 minus 7, 2, and 5 minus 4, 1, and 2 minus 2, 0. Yeah, so what was that? That was 9. Goes in 9 times, and then there's leftover, but it says how many whole sections. So we don't have to figure out the leftover. There we go. You can make 9 whole ones, and then you'll have some board left over. And guess what? We're on number 14 and 15 and 16. Okay, the measurement, which measurement is the best estimate for the mass of a clothespin? So just for you guys out there, my pen's not working. A gram is about the weight of a paper clip or a raisin. And so a clothespin would probably be about 6 grams. Kilograms too much. Kilograms over 2 pounds. Milligrams too small. Okay, which unit of measurement would be most appropriate for the capacity? That's a volume. Capacity, how much will something hold? Like the capacity of the theater, how many people will it hold? The capacity of a soup can, how much will that soup can hold? Grams is a measurement of weight. So no, no. Liters, yeah. So now we're in liters, we're the right capacity. A kiloliter is a lot. That's 1,000 liters. And think about a liter of water. Think about your like soda pops or Gatorade containers. A lot of times they come in liters. A kilo is 1,000 liters. So that would be way too big for a can of soup. Therefore, I'm going to say if we measure that in milliliters, that's 1,000th of a liter. That's probably, milliliter might be a little small, but it's better than a kiloliter. Okay, my computer is having to rest there, but rest is over. Find the difference between, okay, I'll do it. My pen's not working again. Let's see if I can get this to work. Huh. No? That's weird. My pen stopped working. Let me do the old turn off and turn on. Test, test. Now nothing works. See if I can get this to work. Hold, please. Be patient. Close. Huh. Give me 1 minute here. And let's see. I hope we don't stop right now. We're almost done with this thing. I don't know what's going on. My little ink pad is just cut out on me. I don't know how to do a refresh. Word. You're with me? Okay. Let me move down a little. Move up. There we go. It's working again. Okay. Sorry about that delay. Hopefully you stuck around. I added 0 as a place filler. 19.62. And this is where you got to borrow. Okay. You can't take 2 away from 0, so I got to borrow from the 9, make that an 8, and then make this 10. 10 minus 2 is 8. 8 minus 6 is 2. Bring the decimal straight down, and notice how we lined up the decimal. Bring it straight down. 4 minus 9, I can't do that. Make this a 3. Bring 10 over. Now I got, instead of 3, I got 13 because I brought 10 over. 13 minus 9, 4, 3 minus 1, 20. I got 24.28. Hopefully you guys did too. Okay, multiply. We'll do that over here. 6.1, 5.8. We don't have to do anything. Just ignore the decimals for now. 8 times 1 is 8. 8 times 6 is 48. 8 times 6 is 48. 6 times 8 is 48. There's my placeholder. 5 times 1 is 5. 5 times 6 is 30. So 8. 13, carry a 1. 4 and 1 is 5. 35, 38, and then we have 2 decimal spots. 1, 2. Whoops. 2. So we got to move this over 2 decimal spots. And that makes sense. 6.8 is about, 5.8 is about 6. 6 times 6 is 36. 6 times, yeah. So that's a good answer. I like that. 35.38. And we got one last division. Do not round your answer. 1.78 divided by 6. Bring your decimal straight up. 6 goes into 51 8 times, because 6 times 8 is 48. Boom. And 51 minus 48 is 3. Bring down the 7. 6 goes into 37 6 times. 6 times 6 is 36. Bring down a 1. Nope. 37 minus 36 is 1. Now we bring down the 8. 6 goes into 8 3 times. So this one is 8.63. I don't know if I can write it in the box. 8.63. There you go. Convert 6.8 to centimeters to millimeters. Well, there's a lot more. Millimeters are very small, very small. And there's 10 millimeters for every centimeter, so I'm going to convert that to 68. Okay, now we're down, hopefully our last one, because this computer is about done. Put the following list of numbers from in order from smallest to largest. So let's just look them over. Okay, if they were money, this would be the least, $10.08. So I'm going to make that 1. And then 1109, 1110. 1109 is smaller than 1110. So 1109, if I had $11.09 versus $11.10. And even with this, I could round this up to 1110, but this would still be a little smaller. 2, 3. So we got those two out of the way. Then 1129, yeah. 1129 is bigger than 1110. That's $11.10. This is $11.29. And that this leaves 12. So number 5, the very largest. There you have it, you guys. Thanks for your patience. Hope this was helpful. Good luck on your tests. See you later.